All right, first thing we're going to write down is a rational number. All right, you remember when you were very little and you had just your counting numbers, 1, 2, 3, 4, 5, blah, 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 blah.
Yep.
And then as you got older, you learned fractions and decimals and zeros and then a bit, even older negatives. Do you guys remember that?
Yeah.
All right, and you dealt with like whole numbers and integers and so forth. Yes? Well, there's different, when you're dealing with numbers, there's different, you can break them up in different ways. Integers are positive and negatives, no fractions. I'm sorry, with fractions. And so forth. So, a rational number is another way to break up your numbers. Eventually, we'll break them up using real numbers and imaginary numbers, but that'll come another lesson. For now, we're just going to deal with rational and irrational. Got it? Okay. Rational number is a number that can be written as a fraction. A number that can be written as a fraction of whole numbers. I'm going to call it P over Q. So not a decimal over a whole number, but a whole number over a whole number, or an integer over an integer. All right, so it is a number that can be written as a fraction. All right, so let's get some examples of what they're going to look like. Now these numbers can be positive or negative, so I'm going to give you some. 2/3, would that be an example of a rational number?
Yes.
What about 5? 5 isn't a fraction, but can we write it as a fraction? Yes, because 5 is equivalent to what? 5 over 1. All right, -3. Does it matter that it's negative? Nope. Does it matter that it's not a fraction? No, because I can write it over 1. Three over 8, comma, square root of 36. Now I will tell you right now, typically radicals do not work. Why would radical 36 work? Yes?
Because the square root is 6.
Because the square root of 36 is 6, and 6 over 1 is a rational number. So in order for a radical to be rational, it would have to be the square root of a perfect square, or the cube root of a perfect cube. Does that make sense?
Yeah.
So if I had given you square root of 5 or square root of 8, would that have worked?
No.
No. All right. Questions on what is a rational number? Okay. Irrational. Irrational number is a number that cannot be written as a fraction. Again, key word here that it is not, you cannot write it as a fraction. A number that cannot be written as a fraction of whole numbers. So I cannot write it as P over Q. All right, let's get some examples down. I gave you some examples just about a few minutes ago when I said up here, I said, what about this number? And you guys said no. What about that number? And you said no. What were they? They were square roots of, I said square root of 5 and square root of 8 because those are not perfect squares. What if I wrote it like this? 3 plus root 7? That is it's still irrational. If I have a rational number plus an irrational number, it is irrational. Got it? 3 plus root 7. Can I take 3 plus root 7 and write it as P over Q? I cannot. Okay. Comma. What about a number that we were using a lot last unit? Pi. Why is pi irrational? Because it's a fraction that goes on forever. It's non-ending and non-repeating. There's no pattern to it. All right. So I can never write pi as a fraction. I can get pretty close, and you may have worked with the fraction back in middle school. Your teacher said, use this fraction for pi. That's a close, very close approximation, but is it exact? No. Pi can never be written as a fraction of P over Q. Got it? A number that goes on forever, non-ending and non-repeating, cannot be written as P over Q. Questions? All right, another one. This, you're going to think, like, what the heck is that? E. Why are we throwing letters in here? Pi is a letter. No, we use I for imaginary. Pi is a letter that we use to represent the 3.14, blah, 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 blah. E is another number that's actually in your calculator, 2.7 something or other one. Let's see if I can work it in here. Yeah, 2.718281828 da 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 da. Now it looks like there's a pattern here, but there is not. It does not repeat or a pattern. So your E key is right here above your LN key. So it's a number that you have in your scientific calculators. It's right there. You will use that key when you get to higher level math classes. So e to the first power, and you can see the decimal there. It only gives you part of it, like it's like pi, where we use a letter to represent a number. You will see this, banks use this when you're talking about investing money, working with interest rate, kind of stuff is where you will see it. And it does come up here naturally as pi does as well. Okay, questions on rational and irrational numbers? No questions? All right. We are going to do some examples. Simplify. Simplify the radical expressions, and then decide. Simplify the radical expression and then decide if it is rational or irrational. All right, we're listening. Okay, number one. Elementary school. We're taking a trip back to elementary school. 5/8 plus 3/5. Megan.
She looked.
5/8 plus 3/5. All right, adding fractions. Elementary school concept. What is it, about 5th grade-ish? Yeah. Finding a common denominator. What's the common denominator going to be in this case? 40. So I have to multiply each one by its number. So 5/8 I multiply top and bottom by what? 5. Why 5? Because 5 times 8 is 40. Why 5 over 5? We've talked about it before, because 5 over 5 is equivalent to what number? 1. And you guys remember that word? 1 is the multiplicative identity. Multiplicative identity means you can multiply by 1. So if I multiply 5/8 by 1, am I changing its value? No, I'll change the way it looks, but it's still worth 5/8. What's 5 times 5? So 25, not 20. 25 over 40 is equivalent to 5/8. All right, next one, what do we multiply top and bottom by? 8. And 8 times 5 is 40. 3 times 8 is 24. And again, we do 8 over 8 because 8 over 8 is equivalent to 1, and 1 is the multiplicative identity. All right, good. What's 25 over 40 plus 24 over 40?
49.
49 over 40. Reduce if possible. Can I reduce 49 over 40? No. Rational or irrational?
Rational.
Rational. I'm going to put an R for rational. So you have two answers. Your answer and then an R or an I, depending on if it's rational or irrational. Yes? Yes. All right. Number 2. Negative 1/2 plus root 2. Negative 1/2 plus root 2. Guys. All right. Thank you. Okay, did you guys hear what he said? He said change the root 2 to root 2 over 1. And then good job, we're going to do the same thing. We're going to find a common denominator. What's the common denominator going to be? 2. Does the negative 1/2 change, or is it going to stay negative 1/2? Because it's 2, the negative one's going to stay negative 1. Do you see that? Yeah. The second one, I'm going to multiply top and bottom by what? Why 2? Because I want it to become a 2 in the denominator, and 1 times 2 is 2. Yes? Why 2 over 2? Because 2 over 2 is what? All right. Root 2 times 2 is 2 root 2. Why does, now keep in mind, root 2 times root 2 is when the radicals cross out. Does this 2 on the outside have a radical? No. Since there's no radical, we've talked about this before, guys. If you're multiplying a radical by a non-radical, you cannot multiply them together and get like root 4. The 2 goes to the outside and it's 2 root 2. Got it? Okay. Question so far? Now, common denominator is 2, so I'm going to write the fraction as 2, but these are not like terms, so negative 1 plus 2 root 2 would be the final answer. Negative 1 plus 2 root 2 over 2. Is it rational or irrational? Okay, rational can be written as a fraction of 2. Please stop the talking. A fraction of 2 whole numbers. 2 is the whole number. Is the top one, is the numerator a whole number?
No.
No. So rational or irrational? Irrational. I'm going to put in IR for irrational. Okay. So here, when I'm adding up two do you think there's any way to add up 2 rational numbers and get an irrational? Do you think that's possible? I ask you this because they'll ask you these questions on homework tonight. It's not possible to add up 2 rational numbers. It's not possible to add those 2 together and get an irrational. All right. Number 3. 7 root 10 plus root 10. Seven root 10 plus root 10. Now here's how you treat this. Treat it like an x. What's 7x plus x? I'll give you a hint. You're thinking of times. What's 7x plus 1x?
8x.
8x, right? So what's 7 root 10 plus 1 root 10?
8x.
8 root 10. Now, I will tell you this. I put the 1 in there, but is that going to be there?
No.
It's not. Should you know there's a coefficient of 1 there?
Yeah.
Yes. All right, rational or irrational?
Rational.
IR. Why? Because root 10 is not a perfect
Oh, yeah.
squared. All right, number 4. Getting a little more difficult. 4 plus 7 root 17 in parentheses, plus parentheses 5 plus 3 root 17. Gentlemen.
It's so disrespectful.
All right, right here. I'm going to cover this one. Is that rational or irrational? What about that one? Okay, so we're adding 2 irrational numbers together. Now, where kids are mistaken, they treat this as a double distribution. Does it look a lot like if I were to cover that and say that's multiplication, would that be a double distribution? Yes, and we've done that before. This is not a double distribution because what sign is in between? Plus. So I distribute that positive sign, 4 plus 7 root 17, plus 5 plus 3 root 17. Chauncey? All right. It's just the same. Shh, guys, when you're adding up two numbers, the distributing the positive does not change what you are adding. So, can you just pretty much drop the parentheses and add? Yes, I'm going to repeat the question. Can you pretty much just drop the parentheses and add?
Yes, you can.
What if that was a minus sign? Would you be able to do the same?
No.
No, because you'd have to distribute the negative, and that does change things. All right, treat this just like you would with like terms. What's 4 plus 5? 9. And then 7 root 17 plus 3 root 17 is 10 root 17. All right, so again, you add them like you would variables. Please stop the talking.
Do we just leave it as that?
And that's it. Why can I not add these two numbers together?
They are not like terms.
Thank you. One has a rational, one does not. One has a radical, one does not, and they're not like terms. Rational or irrational?
Irrational.
Irrational. Okay, questions? Okay, number 5. So I'm going to show you one. Like, yes.
If the square root is a number like 36, would we bring it down to a 6, but if there were more numbers like a plus like 7 before it, would we add the 6 and the 7? Okay.
All right. So this is similar to the one we just had. And what did I just say? Can I
said
drop
you
the
can't.
parentheses?
No.
No, because there's a what sign? So you do have to distribute that minus, and the minus does change things. So the first chunk will stay the same. It'll still be 3 minus 6 root 5. But here is going to be what? Up front. Thank you. Negative 4 minus 7 root 5. And we're going to treat it just like we did the last one. 3 and negative 4 add up to what? Negative 1. Negative 6 and negative 7 add up to negative 13, and the root 5 stays there. Now, when you're adding, it doesn't undo. If you were doing root 5 times root 5 or root 15 times root 15, they undo each other. Does that happen when you're adding? No, when you're adding, they stay. Like 2x plus 5x is 7x. Got it? All right, rational or irrational? All right, before I show you the next one, what can we say about adding irrational numbers? If I add two irrational numbers, are they always going to come out to be irrational, or do you think they could come out to be rational? They could? You think they could? Okay, we did these two irrational numbers, and did it add up to an irrational? I added these two irrationals, did it come up to be an irrational? Yes? I added up these two irrationals, and it came out to be an irrational. Do you think that's always going to be true? He said you disagree. You don't think it's always going to be true. Anyone else? You don't think it's always going to be true? Okay, maybe, maybe not. We are going to try some more because, again, they will ask you these type of questions not only on homework but on the test. Okay, number 6. 7 plus 9 root 5. Is that irrational? No. Is that irrational? Yes. All right. I'm going to come back over here. I said adding, but is adding and subtracting the same concept? Yes. All right. 7 plus 9 root 5 minus parentheses 4 plus 9 root 5. Are both of these irrational numbers? Can I drop the parentheses? No, I have to do what first? On the first part I can. He is correct. The first one I can, but the second one I do have to distribute. Do you guys think this is going to be rational or irrational?
Rational.
Rational. Just a guess, or do you see anything?
Just a guess.
Yes.
You distribute the negative to the 9 root 5, and they cancel out each other.
Good job. So she's looking ahead. Do you guys see what she sees? All right. I'm going to write it down. I keep losing my pencil.
It's right there.
All right. 7 plus 9 root 5. Take away 4. Take away 9 root 5. Now what Gabby said is right here when you distribute, that becomes negative. When we combine these two here, what's going to end up happening? They cancel each other out. So we're left with 7 and negative 4, which is 3. Is it just 3 by itself? Yes. Rational or irrational? So it's not common, it doesn't happen very often, but is it possible to add 2 irrational numbers and get a rational?
Yes.
Yes. It happened right here. Now listening, please. Those of you that are not paying attention, you will be struggling because there will be a whole back page on tonight's assignment that's asking you those questions I've been asking you as we're going along. And you need to be paying attention because those questions will come up again when?
On the test day.
On the test day. And the quizzes. All right, number 7. The next piece we're moving on is to multiplication. So I'm going to go quickly with this first piece. 1/2 times 3/5. I'm going to cover that up. 1/2, rational or irrational? 3/5, rational or irrational? Any thoughts about when you multiply 2 rational numbers? You will always get a rational. When I multiply, I just multiply across. 1 times 3, 2 times 5. What do I get?
16.
3/10. Right?
Yes.
1 times 3 is 3, 2 times 5 is 10.
Yes.
Yes, not diagonal, not cross, not across. All right, rational or irrational? Rational. All right, number 8. Root 2 times 2 root, I'm sorry, not 2 root, 2 over 5. Root 2 times 2/5. All right, he's already saying irrational. First off, this first one's rational or irrational? Irrational, this one is rational. Any thoughts on what it's going to come out to be?
I'm going to say irrational.
Irrational. Do we do what?
The irrational numbers. It would be 2 over 5.
Root 2. We're actually going to multiply like this. Do you guys agree I can put a 1 underneath?
Yeah.
Yes. Can you guys please knock it off and pay attention? All right. What's 2 times root 2? 2 root 2. There's no. I can't say root 4. I can't say just root 2. It's like 2 times x is 2x. 2 times root 2 is 2 root 2. All over 5.
Oh no, it crashed.
Is it rational or irrational? It is irrational. So you guys were right. Why is it irrational? Because 2 root 2 is not a whole number. Right? A fraction of whole numbers. Okay. Questions? All right. Any thoughts? Is there any, if we're multiplying to two,
This is fun.
if we're multiplying, good. If we're multiplying two rational numbers, is there any way to get them to be irrational?
Yeah.
If we're multiplying two rational numbers, a whole number times a whole number, is it ever going to come out to be a radical?
No.
No. What about multiplying rational and irrational?
It can be
Either? Okay, we'll keep trying.
Oh,
That's
it's
because
always
of
going to be
radical.
irrational.
If one is rational and one is irrational, yes, it's always going to be irrational. What about two irrationals?
It could be either.
That one could be either. You are right. All right. 7 root 5. That's a 5. 7 root 5 times 2 root 3. All right. We multiply like terms, like 7 times 2 and root 5 times root 3. What's 7 times 2? 14 and root 5 times root 3?
15.
Root 15. Now, when you're multiplying, they do not need to be like terms. You can multiply radicals together. It's not like addition where the radicals have to be the same and you only add the coefficients. Multiplying, you just multiply. 14 root 15, rational or irrational?
Irrational.
All right. So, Cole said earlier it could be either. So this one came out to be irrational. Anyone want to agree with him? Or do you want to say it's always going to be
I would
irrational?
hope you guys would all agree with me, 'cause that's-
I agree with Cole because like he's
I guess it could come out rational, but that would have to do with putting two of the same radicals.
Good job. Did everybody hear her? Okay. Here is what she said. She made a very good observation. She said, this one came out to be irrational, but you could have the product of two irrationals be rational if the two of them were the same radical. Why would she say that? What's root 10 times root 10?
root 10.
No.
10.
10. Is the radical gone?
Yes.
Yeah. Yes. So then it's just 10 times 7. So it's 7. Root 10 times root 10 is 10, which comes out to be 70. So Cole was correct when he first observed that, hey, when I'm multiplying, it could go either way. It could be irrational or it could be rational. The other kind of test question they're going to ask you is to give examples. Give examples of two numbers that are irrational that multiply to be a rational. Something like this. Do you see that? All right. Questions? Okay. We are almost done. What about this one? This is another tricky one. Take a quick look. We ready?
Wait, I didn't see the.
I know, I'm going to give it to you. Rational or irrational?
Ear.
Irrational.
IR.
What about that one?
Ear.
Irrational.
Here.
They're not the same the way Gabby said. They're not root 10 and root 10. So are they going to come out to be rational or irrational?
Rational. Because 3 times 12 is 36.
Perfect. Okay, so Gabby pointed out that they should be the same, which is true. Now, is that always true? No, because is 3 the same as 12? No, but what is 3 times 12?
36.
Okay, so it didn't cross out the radical like the 10 and the 10 did over there. But is 36 a perfect square?
It is.
It is. All right, so we multiply the coefficients first. What's 5 times 2? 10 root 36, which is 10 times. Oh, you're a step ahead of me. 10 times, what's root 36?
6.
6, so 10 times 6 is?
60.
60, which is rational or irrational?
That means rational.
All right, so it's just going back to what we said. When you're multiplying two irrationals, it just depends on the problem. Some of them will stay irrational. Some of them will become rational. Do they always have to be the same?
No.
No, as long as they multiply to be perfect squares, we're good. We will. Shh. All right. This one. There's no multiplying, but you're just simplifying. And we're going to speed things up a little here. Root 75, before I break it up, rational or irrational?
Irrational.
How do we know it's irrational? Because it's not a perfect square. Can I simplify it? Yes, but it's still going to be irrational. What does that break up to?
25 and 3.
25 and 3, and 25 is
5.
5 and 5. And do we have a pair to come out?
Yes.
So the 5 comes out as just 5. I'll write it out. 3 times 5 times 5. The 5 comes out. What does this simplify to? 5 root 3. Rational or irrational? Irrational. Okay, do you see that?
I see it.
Okay, we're going to do another few quick ones, and we're going to move on to division, and that's going to go pretty fast as well. I know. 13, root 5. Is there any simplifying to do? Oh, we have enough time. We can't simplify. Rational or irrational? All right. 14. Square root of 144.
What?
Square root of 144. Can I break it up? And before I even break it up, rational or irrational? How can we tell it's rational? Because 144 is a perfect square. So what's the square root of 144? 12, and that is rational. All right, last two. 15. 3 root 12 over root 3. 3 root 12 divide by root 3. Can anybody do it in their head? Okay. Her question was, yes to your question. Her question was, can we just divide? Yes. If they're both in radicals, you can simplify. So this becomes 3 root 4 because 12 divided by 3 is 4. Rational or irrational? Ooh. Why? I didn't finish it purposely. Why is it rational?
Why did you do that?
Because 4 is a perfect square, so this becomes 3 times 2, which is 6, and 6 is rational. Last one, 16. 10 root 24 over 2 root 3. This one does take a little while, so I want you working it out as I get your worksheets ready to hand out. Can you divide the 10 and the 2? Yes. Divide the 10 and the 2, divide the 24 and the 3.
8's a perfect square. Wait, is it?
40's not a root of a square, is it?
40.
Yeah.
That's 8.
Multiply. 8 times 5. 5 and 3.
All right.
Yeah, come on.
Rational or irrational?
Irrational.
All right, what's 10 divided by 2?
5.
5.
8.
5 root 8. Now,
Yes.
listening. Is root 8 a perfect square?
No.
So before I go any further, is this irrational?
Yes.
Now, I will tell you this. If you put this as your answer on the test, it's wrong.
Oh, you're going to get smacked.
Why? What can I still do with root 8?
Multiply it.
Break it down is correct. What does 8 break down into?
2 and 4.
2 and 4. And 4 is... So I have 2, 2, 2. Please stop the talking. What comes out?
5 root 2.
A 2, and that 2 multiplies with that 5, which is
8. I mean 10.
10 root 2. All right. Be careful with those. Good day.